on October 2025. It was a streak of light that broke all the rules, moving too fast, glowing without cause, and vanishing from NASA's servers the moment the world started looking. But one frame changes everything. A razor-thin line stretches across the Martian sky, vanishing between exposures. Measured against known stars, it's moving at 60 kilometers per second, fast enough to circle Earth in 7 minutes. For a planet with almost no atmosphere, the implication is chilling. Nothing natural moves like that above Mars. Hours later, an amateur astronomer named Stephen Burns downloads the full data batch from NASA's servers. He's methodical, not a headline chaser. He corrects distortion, cross-references, timestamps, and stacks the images by hand. The streak holds frame to frame, pixel to pixel. He posts his findings online with one line: "If anyone can break this, do it." Within hours, the data explodes across astronomy forums. If this kind of space mystery grabs you, like this video and subscribe now for more space mysteries and updates. Now, professionals, hobbyists, and even skeptics scramble to replicate the signal. Some confirm it, others accuse Burns of overfitting noise. But then something stranger happens. One reprocessed stack shows a flash of green, a single-frame bloom that lasts less than 1/10 of a second. If it's real, it could mean chemistry, a dicarbon emission, the kind that makes comets glow emerald as sunlight tears their bonds apart. But there's a paradox. The Mars Trace Gas Orbiter's preliminary spectra show no sign of dicarbon at all. So how can something shine green with no C2 present? At the same time, interstellar Comet 3 I-Atlas is racing past Mars at nearly 124,000 miles per hour, following a path calculated months earlier. The alignment is almost perfect. The timing fits to the minute. If Burns's streak really is Atlas, then this is the first time humanity has ever caught an interstellar object, crossing another planet's sky. But then, silence. The next morning, Perseverance's public image feed stops updating. High-rise data, usually posted within hours, freezes. NASA's archive displays a maintenance banner. Uploads delayed during system calibration. Across the world, astronomers wait. The European Space Agency releases low-res Mars Express images showing a faint diffuse glow in roughly the same region, but nothing conclusive. And that only fuels the debate. Something passed Mars that night. Something the American datasets no longer show. Inside JPL, engineers review the raw frames in silence. Each file is checked for cosmic ray hits, tracking drift, hot pixels. The problem is scale. At Mars's distance, even the most powerful camera can only resolve features tens of kilometers wide. A single misaligned pixel can turn a faint dot into a phantom. Every frame must be calibrated manually, cross-matched to star catalogs, frame-aligned, and statistically filtered before release. One false artifact could ignite panic. For the public, though, the timing is unforgivable. NASA's data blackout starts just as the object crosses Mars, the moment scientists have waited for since Oumuamua. Rumors multiply. Was it a power issue? A data lag? Or deliberate caution? NASA says nothing. Meanwhile, independent teams try to fill the gap. Amateur astronomers run photometric simulations, modeling what a 60 kilometers per second object would look like through Perseverance's lens. Their models match Burns's result almost perfectly. Others, however, claim the entire event is an illusion, a cosmic ray burst caught mid-exposure. Yet cosmic rays leave sharp spikes, not smooth streaks. Burns's line is curved ever so slightly, matching the predicted parallax of a body in motion, not a random hit. For once, the math is stranger than the myth. As debates rage, Mars's orbiters, MRO, TGO, Mars Express, continue scheduled imaging runs, but none release new visuals. Instead, whispers leak from inside teams. Calibration conflicts, solar particle interference, imaging drift caused by recent coronal mass ejections. It's all plausible, but none of it explains the green flash or the perfect alignment with 3 I-Atlas's path. Back on Earth, the object's trajectory seems impossible. Unlike previous interstellar visitors Oumuamua, which plunged steeply through the solar plane, and Borisov, which came in from above the ecliptic Atlas, slides almost perfectly along it. It threads the planetary system like a bead on a string, gliding past Mars, then curving toward Earth and Jupiter. The odds of that happening by random chance? Less than 1 in a million. Avi Loeb's group calls it a choreography too precise for coincidence. Others dismiss that as speculation. But the facts remain. The object's speed, its low inclination, its resistance to solar drag all are statistical outliers. Then, the chemistry deepens the mystery. Spectral data from ESA's trace gas orbiter show an elemental ratio flipped from every known comet, nickel dominating, iron nearly absent. In meteorites and comets, iron is always higher. Only engineered alloys reverse that ratio. The nickel-rich signature echoes something industrial, refined, or forged. And that's when the artificial probe hypothesis resurfaces, whispered first in 2017 with Oumuamua, dismissed, then reborn here under a Martian sky. As scientists parse the data, the numbers grow stranger. The mass of Atlas is estimated at over 10 billion tons, far denser than expected for a comet venting visible gas. The jets that should push it off course don't. Its trajectory follows pure Newtonian prediction, as if no outgassing exists at all. The official stance remains cautious, unusual but natural. But private discussions among orbital analysts sound different. Too stable, one says. Too perfect. Meanwhile, Perseverance remains silent. For 10 days, no new night sky images are uploaded. When data finally returns, it skips over the October 2-4 interval entirely. Those frames, the very ones Burns analyzed, never appear in NASA's main archive again. The public's patience cracks. Some blame the government shutdown earlier that month. Others see censorship. NASA issues a single-line statement. Processing delays due to calibration updates. No anomalies confirmed. The ambiguity only makes it worse. Still, a few raw metrics escape through ESA channels. They show that during the flyby window, Mars's orbiters recorded a sudden, short-lived surge in localized ion density, tiny but measurable. Was it coincidence, or the signature of something interacting with the solar wind in ways we don't yet understand? As weeks pass, the debate moves from data to theory. Some astrophysicists insist the green flash was an imaging artifact. Others counter that the correlated timing with nickel emission lines is statistically impossible to fake. The deeper they look, the more contradictions emerge. And at the center of it all, 3I Atlas continues on course, untouched, unwavering, silent. It passes Mars and slides toward the inner system, invisible behind the sun's glare. Every telescope on Earth turns away, forced by solar safety limits. For 6 weeks, it vanishes completely. During that blackout, speculation explodes. If the object is truly interstellar, it's now enduring its greatest test exposure to the full pressure of the sun's radiation and magnetic fields. Ordinary comets fragment. Artificial structures might adapt. Which will it be? By late October, the solar system becomes a stage set for tension. Scientists model every outcome. Will the object disintegrate, brighten, fade, or maneuver? Each scenario carries implications far beyond astronomy, and still, no new images. The final confirmed visual remains Stephen Burns's streak across the Martian sky. One trace, 9 minutes long, unrepeatable. A single white line calms Stephen Burns. Red dust, whispering the same question that haunted Oumuamua. What if it isn't natural? For 35 days, the sky says nothing. 3I Atlas has slipped behind the sun beyond every camera, beyond every receiver. The world waits for light that will not come. Behind that brightness, physics does its work. Radiation pressure climbs. Solar wind folds magnetic fields like origami. Any ordinary comet would boil, fracture, scatter. But if Atlas is ordinary, it should already be gone. Weeks pass. No debris appears, no diffuse tail reported by coronagraphs. The object simply refuses to behave like ice. At observatories across Earth, the blackout becomes a ritual. Scientists running nightly simulations with no new data to feed them. Amateurs posting countdowns until conjunction ends. When something vanishes, human imagination takes its place. Theories multiply, self-shielding crusts, exotic alloys, even active control. Each hypothesis leaves the same hollow echo without images, no proof. Then, December 1st arrives. Dawn over Chile. The first telescopes turn toward the eastern horizon. At first, nothing. Then, a faint, unfamiliar glow low above the sun's glare, an arc of emerald bending against the stars. Observers think it's a reflection, but the coordinates match exactly where 3i Atlas should reappear. The visitor has survived the sun spectra start streaming in. The color that once puzzled scientists green without dicarbon returns, stronger than before. But again, no swan bands, no C2 fingerprints. Instead, the light curves show metallic emission. Nickel, cobalt, traces of silicon carbide. Not volatile ice, but heated composite. The new images reveal geometry. Not a ragged coma, but filaments 3, maybe 4, spaced evenly along the primary axis. They hold their formation for hours. Engineers call them companions, skeptics call them artifacts. Yet they move together, locked in perfect relative distance as the entire cluster drifts across the field. Natural fragment trains don't stay synchronized, they spread. But these don't. Their drift is measured in meters per second when it should be hundreds. Something is maintaining cohesion. Gravity can't, self-binding is too weak. Outgassing thrust would scatter them, not align them. Every rule of comet dynamics falls apart in that frame. ESA's Mars Express confirms faint polarization anomalies, light scattering backward instead of forward, the hallmark of microstructured or metallic surfaces. The numbers echo lab experiments with engineered foils and hollow shells, not dust. What kind of interstellar body carries a surface that behaves like brushed metal under sunlight? As the evidence grows, so does resistance. Committees form to audit the data. Analysts comb for cosmic ray contamination, compression artifacts, anything that could explain away the impossible. But the more they clean the images, the more consistent the geometry becomes. 4 luminous nodes, equidistant, rotating slowly as one. And then comes the radio test. Loeb's team at Harvard points a narrow-band array at the returning coordinates. Centered on 1,420 MHz, the hydrogen line, the cosmic neutral frequency. For 3 nights, they hear nothing. On the 4th, a faint pulse spikes above background 3 narrow pips, spaced exactly 10 seconds apart. Too weak for certainty, too structured to ignore. The data is released raw, without commentary. Half the community dismisses it as terrestrial interference. The other half quietly reruns the filters and finds the same pattern. No Doppler drift, no harmonic spread, just 3 clean tones buried in static. Coincidence, or call sign? By mid-December, Atlas approaches its closest distance to Earth, 1.8 astronomical units. Brightness rises sharply, then plateaus instead of fading. Observers expect a tail broadening as sublimation increases. Instead, the plume narrows, focusing toward the sun like a controlled jet. Dust. Models can't reproduce the shape without invoking dense, refractory material rock or alloy. Meanwhile, radar reflections from the Goldstone network bounce faintly off the object's trajectory. The return signature isn't diffuse, it's specular, as though reflecting from smooth planes. Radar brightness spikes at regular intervals, perhaps rotation, perhaps facets. Either way, not random. Commentators draw parallels to Oumuamua's reflective behavior in 2017, but Atlas amplifies the puzzle by orders of magnitude: heavier, brighter, geometrically coherent. Whatever it is, it's holding formation through the sun's radiation like a ship surfing a wave, and still, the official line remains conservative. Unexplained photometric features consistent with non-standard comet morphology. The words mean everything and nothing. Inside the labs, scientists whisper their disbelief. Off-the-record comments leak to forums. If it isn't artificial, it's the strangest natural object ever found. Then, in early January, the unexpected happens. A sudden increase in reflected brightness, nearly 0.8 magnitudes in 2 hours. Too fast for rotation, too slow for explosion. When the light curve stabilizes, a 5th node appears in the formation, faint but steady. If fragments are breaking off, they should drift apart. Instead, spacing readjusts, symmetry preserved. The configuration flexes like a mechanical structure repositioning itself. Telemetry from ESA's solar orbiter registers a corresponding blip in local particle density, a thin sheet of plasma passing the probe moments before the brightness change. Timing coincidence? Maybe. Or maybe the object just did something: fired, vented, maneuvered. In response, agencies tighten their data. No further public releases. Amateur observations are now the only open window. But even their frames begin showing subtle interference streaks that vanish on upload, checksum mismatches, unexplained noise. The sky feels scripted, and yet, through all the static, one fact remains steady. The orbit hasn't changed. 3I Atlas stays precisely on its predicted gravitational path to within a fraction of an arcsecond. No tug, no thrust, no measurable deviation. It acts like mass without motive force, yet the visuals tell another story. Scientists call this duality the Atlas paradox, something that looks engineered but moves like stone. A mystery balanced between motion and intent. By February 2026, the interstellar visitor begins its outward climb, trailing a wake of questions. Data analysts publish provisional results, the nickel-to-iron ratio confirmed, the anti-tail verified, no measurable outgassing acceleration detected. The green flash remains unconfirmed but persistent in independent stacks. The 1420 MHz pulse remains unexplained. The final composite from Mars Express shows a narrow, luminous rod, slender, axis-aligned, its brightness oscillating with a 10-hour rhythm. Some call it rotation, others call it signaling. The distinction now feels almost philosophical. As the object recedes, so does certainty. Every model breaks somewhere. Some try to fit it into exotic physics, superdense outgassing jets, coherent magnetic dust, fractal aggregates. Others quietly admit that nature rarely writes equations this neat. In the end, the cosmos doesn't answer. The visitor just keeps moving past Jupiter's orbit into darkness, carrying the questions with it. If history is pattern, the next interstellar object will arrive soon, and everything we learned or failed to learn from Atlas will shape how we see it. So stay tuned, stay skeptical, and above all, stay watching. Because somewhere beyond the heliopause, another wanderer is already on its way, perhaps ice, perhaps rock, or perhaps something that remembers what it saw when it passed our red world and found our cameras waiting.